Hit ya, back split ya. Fuck fist fights and lame scuffles. Pillowcase to your face, make the shell muffle. Shoot your daughter in the calf.
Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. I'm going to help you by going over some math concepts and examples. Good luck.
So for our next example, we're going to use this word problem. So we have we're pumping water into an inverted right circular conical tank at the rate of 5 cubic feet per minute. The tank has a height of 6 feet and the radius on top is 3 feet. We're trying to find the rate at which the water level is rising when the water is 2 feet deep. And they give us the formula for the volume of the cone. So first, let's draw a picture. We have an inverted right side, like this. So what it looks like, and it has radius r, and it has a height h. And what I like to do is I like to write down formulas, and then I also like to write down the other information they give us. So they tell us that the rate at which the water is being pumped in is 5 cubic feet per minute. So we know that dV dt, which rate of change of volume, is 5 cubic feet of feet cubed per minute. Okay, and then we know the height is 6 feet. So that's the total height. So we'll actually call that capital H. And that is 6 feet. And we know that the radius on top is 3 feet. We'll call that capital R. So, and we're trying to find the rate at which the height is changing. So we're looking for dH dt when the water is 2 feet deep. So current height H is 2 feet deep. So around here, H equals 2 feet. So now we kind of want to get this in a. Right now we have 3 variables. We prefer to have it as a formula with 2 variables. So we can find a relationship between R and H. And we get that by looking at this, by using similar triangles. So have R, capital R, and H, capital H, sorry. But if, as the water level is rising, we also have the current radius of the cone and the current height of the cone, lowercase r and lowercase h. And by similar triangles, we know that r over h, capital R over h should equal lowercase r over lowercase h. So we know that capital R is 3 feet, lowercase capital H is 6 feet, so the ratio is 2. So this tells us that H equals R over 2. So if we plug that into our formula, we get B equals 1/3 pi R squared times H, which is R over. That gives us B equals, we have 1/3 times 1/2, so 1/6 pi R cubed. And if we differentiate both sides, we get d dt that gives us the dv dt equals 1/6 pi times 3r squared dr dt. And we want to solve for, actually, in this case, what I should have done was get everything in terms of dh dt. That would have made things easier. So everything should have been in terms of height. Go back, it's okay. If you do this, I mean, there are ways you can do it like this, but I'll show you what I mean. Instead of solving for h, let's solve for r. R is 2h. Now if we plug that in, we get that b equals 1/3 pi times 2h squared times h. Gives us that b is 4/3 pi h squared, h cubed, sorry. Now if we differentiate both sides, we get dv dt equals 4/3 pi times 3h squared dh dt. 3's cancel. We get dv dt equals 4 pi h squared dh dt. And we're solving for dh dt, so dh dt equals dv dt times 1/4 pi h squared. Now we know that dv dt is 5 feet cubed per minute, so 5 feet cubed per minute. And we know that h is currently 2 feet. So 2 feet squared. That gives us 5/16 pi feet per minute as dh dt. That's the rate at which the water level is rising at that moment.
Jay-Z, big smalls, nigga, shit your drawers. Brooklyn, represent y'all, hit your fours. You crazy, think a little bit around.